Okay, now the better method, if you can do it, is actually use a sampling technique known as inversion sampling. Okay, so now let's say we have a PDF that looks like this. Okay, so let me draw this here. We have the probability density px here, and we have here, for this example, two possible values, x1 and x2. Okay, now imagine that I have my PDF like that. Okay, so let's say this is the probability of this one. Maybe I can draw this a little bit larger here. I can extend this here. Okay, so let's say the probability of x1 is 2 over 3. It has higher probability, and the probability of x2 is 1 over 3. Okay, now here this is not uniform probability, right? So I have x1 and x2, and the probability of x1 is 2 over 3, and the probability of x2 is 1 over 3. Okay, now I want to do sampling that is proportional to this probability, let's say. Okay, I want to do sampling. Now, how can I do sampling proportional to this probability? Okay, so now this is where the inversion sampling will come into the picture. So first, this is the PDF. Okay, this is the PDF. Now from here, the first step is to compute the CDF. Okay, so CDF stands for cumulative density function. Okay, PDF was probability density function, and CDF is cumulative density function. Now the CDF is kind of like computing the cumulative histogram. So for x1 we have again this, okay, 2 over 3. So this is CDF. Okay, this was PDF. Now for x2 it's cumulative, right? So you add up, you basically add up. Okay, so this becomes 1. So the CDF, the maximum value of the CDF should be 1 because the probabilities should add up to 1. The summation of all the probabilities should be 1. Okay, now this is the CDF. Okay, so it actually can be computed. The definition of the CDF of x is equal to actually this is equal to px. Okay, we write using the capital P. For the PDF we have been using the small lowercase p. For the CDF we are using the capital P. Is equal to this, the integral, okay, from the smallest x min until our x, okay, p, this is the PDF, probability of xi dxi. Okay, so we are basically integrating the probabilities starting with the smallest probability and up to the largest probability. Okay, so I have used integral because assuming that the PDF is continuous. But if the PDF is discrete, and in this case actually it is not called PDF, it's called PMF, probability mass function in the discrete case, this could be a summation. Okay, but this is the general case. So this is how you compute the PDF, the CDF of a function. You compute the integral of a PDF. The integral of a PDF is the CDF. Okay. Now, if we want to if you want to sample, okay, with respect to this. Now, let's say we generate a uniform random number psi, okay, or chi, okay. Chi, again, uniform random number from 0 to 1, as always. Okay. Now here, note that this range here is from 0 to 1, right? This is 0 and this is 1. Now, chi will be uniform, okay? So chi with 2/3 probability, chi will be in this region, right? And it will be with 1/3 probability, chi will be in this region. Okay? So therefore, if you can do the following, you generate a chi here, okay? So let's say chi happens to be here, okay? You generate a chi, and you look up what was my value, okay? What was the x? What is the value on the x-axis? Oh, x1, okay? So I say, okay, my sample value should be x1. So with 2/3 probability, the chi's that I generate, so let's call this chi 1, chi 2, with 2/3 probability, the chi's that are generated will give me x1. And with 1/3 probability, the chi's that are generated will give me x2. Okay? So what we are doing here is we are taking a value on the y-axis and we are computing what it maps to on the x-axis. So this is known as, this is the same as inverting the function. Okay? So actually, this, what we have been trying to do here visually is, you compute the PDF, you invert the PDF, okay? You compute the CDF, then you invert CDF to find this one, okay? Okay, so let me call this like y, okay? And then whenever you give chi here, whenever you give a chi value here, it will give you, so chi I, it will give you xi. Okay? So, and this xi, the nice thing about this is that this xi will have been chosen with respect to the probabilities defined in your PDF. Okay? If you want uniform probability, you can do that. If you want non-uniform probability, you can also do that. Okay? So this is known as inversion sampling. It is made up of 2 steps. Summary. First of all, you choose a PDF. Okay? Step 1. Step 2, you compute the corresponding CDF. Step 3, you invert the CDF. And step 4, you give the chi pseudorandom number, a uniform pseudorandom number, to the inverted CDF to get your sample value. Okay, I said 2 steps, but actually it has 4 steps.